on the far left you have your pin 7 or 8. Well, if you want to set, say, pin 2 high, then you set the second bit of the register to 1. Or if you want to set the last 2 bits high, then you'll set the last 2 bits to 1. And this would, in Arduino language, this right here, this assignment, this whole line would be kind of like saying set, LED pin 1 and 2 to high. Digital write high, I think, for those things. So that's a little bit weird. It's a little bit different. I think it's kind of neat because, well, you can just do that with one line of code. So it's a different kind of thinking. And this is just the very beginning, because for this project, I want to do some analog reading, and that is really tricky compared to the Arduino. The Arduino, it's really simple. It's just an analog write kind of thing. And here, you're playing around with registers and timers and all kinds of stuff that's really interesting, but also kind of challenging for me to learn. So what this code right here is doing, in kind of a dumb, clunky way, is I'm just explicitly creating the 8 different states that 3 pins can make. So if you have 3 pins, there's 8 different combinations that they can have. 0, 0, 0, 1, just like counting binary, 0 to 8. I'm sure there's some way to do this in some kind of loop, so that I'm not just repeating the same bit of code over and over again, but I don't really know how to do that. I spent a little bit of time trying to look around, but I didn't find anything too quickly. And this code is not really anything I'm going to use. It's just for demonstration purposes, basically, because the meat and potatoes of the weekend was to show that this concept is a valid one, where I can have a 3 input pins go into a demultiplexer and have those 3 pins produce 8 different outputs. And that's what's going on here. I have 3 pins, my least significant bit and my most significant bit. And back here is just the grounding wire, so that everything is on a common ground. But here I have 3 pins, 3 digital pins controlling 8 different LEDs. That's pretty cool, because normally, if you do most of these Hello World kind of tutorials from Adafruit or whatever, you'd have a single pin controlling a single LED. So this is made possible with this 3 to 8 demultiplexer. Now, the reason that there's such a jungle of wires right here is because I have this demultiplexer, the 8 outputs of that going into these 2 quad arrays of optocouplers. So it's hard to see because of the lighting, but I have 2 optocouplers right here. Each of the optocouplers has, each of these chips has 4 optocouplers on it. And then I'm controlling all the outputs there. So sometime down the road, instead of LEDs that I'll be controlling the buttons on this phone. And the reason that I have this pretty ugly setup where this phone is glued to this perf board is because I'm going to put these chips all around it and be able to control it. And so the idea is to have some kind of analog sensor, like a laser tripwire, be the cue to have this microcontroller use that phone to make a call. So it'd be cool if I could use something like this. My friend gave this to me. It's a photo eye, something that they'd use in industry. I see a lot of these at work, but I don't know. It's look at the power requirement on this. It takes like, I think 12 volts or something to power it. So I don't know. There's other photo sensors out there, maybe like an IR sensor or the ping sensor that can do the same thing but with less power. But it'd be kind of fun to use this. The thing that I guess I'm most I don't know concerned about and a little bit anxious is in the coding for this. When I want to do the analog input, like analog read for something like this, I was looking into it today. It's a little bit trickier than the Arduino. Arduino just has analog write, and it automatically converts your 0 to, I think, 5-volt signal into your digital output, 0 to 1023 bits. And this thing, just like with how this digital writing is a little bit more complicated, the analog read for this MSP430 is also trickier. You're kind of directly manipulating this analog to digital converter. So it's a good learning experience, and there'll be a lot to take away from it. But it's the reason that I didn't get as much done as I wanted this weekend. So we'll see how it goes next weekend. Maybe I'll get a lot more done, and maybe this kind of record will kind of motivate me to try to get more done, so I have more to report. But that's it for this week.